Hey guys, how's it going? In this video, I'm going to go through this leetcode problem word search. I actually have solved this problem before, but they recently add some more new test cases, and that makes it become more challenging. So I'm going to solve it again and optimize the original approach um, just to be able to run through all the test cases. Let's dive into it again. So this problem was asked by Amazon for 31 times in the past 6 months. So it's quite popular. So we are given a m by m grid characters and also a string of word that this is our target. Return true if the word exists in the grid, and the word can be constructed from letter sequentially adjacent cells where adjacent cells are horizontally, vertically neighboring. The same letter cell may not be used more than once. So example, if the board that we given looks like this, and the word that we're searching for is A, B, C, C, E, D. And so we're going to return true because we can find A, B, C, C, E, D over here on the board. First example, and second example is the board looks like this. And the word that we are searching for is C, S-E-E, and we can find on the corner over here. So we're going to return the true again. And for this one, the board looks like this, and the word that we're searching for is A, B, C, B, and we cannot find a word on the board, so that's why we return the false. Also, there's a kind of string over here. We're gonna solve this problem using DFS with backtracking. Let's dive into this algorithm. So first, we have, let me zoom in a little bit. We have a NR and NC, which keep track of the number of rows, total number of rows, and total number of columns. Also, we have the exploring set to keep track of which coordinate that we are exploring, so we don't go back to the coordinate that we are exploring. Because there's a sentence over here, right? Yeah, the same letter cell may not be used more than once, and that's why we need this exploring set to prevent us to go back. And also we have the direction list. So this is all the allowed direction for our exploration. So we basically traversing the rows, the neighboring rows, also the neighboring columns. Okay, and I'm gonna go through the DFS function later. So this is the main two for loops, double for loops to call this DFS function. So if the board at the R and C cell, and that letter is not even equal to the first letter of the word, we don't have to call the DFS function. And this is where I optimized the original solution. The original solution, we didn't have this line, and now I added to it, and this allows us to pass all the test cases. Because if the first word is not even the first letter is not even in the first letter of the word, and we don't have to call the DFS function. So for the DFS function, we take in the row index, column index, also the index of the word that we are looking at. So basically, we have the index. Basically, this is a pointer point to the word that we are given. For example, index 0 will be the first letter of the word. Index 2 will be index of 1 will be the second letter of the word. Okay, so this is that index. So for the DFS function, if so, this is the exit condition. Okay, if the index is at the end, at the last index of the word, which is the length of over -1, we don't have to do the rest. Immediately return true because we have already found the word if we reach to this line. And now let's do some exploration. And before doing the exploration, we have to add the current row and current column to this exploring set. Okay, and for all the directions on along the row side, also on the column side, we just add those directions to the current row and current column, and that will become the next row and next column. Okay, and so this is the, I call it go ahead condition. If we meet these conditions all together, we are allowed to go ahead. So what are the conditions that we're talking about? If the next row and next column are not being explored, and also the coordinate, they are within bound, also the letter that they are on the board is is equal to the next letter on the word, right? So we are okay to go ahead. Otherwise, we are not going ahead. And if we are allowed to go ahead, we just call this new coordinate also the index plus one on this DFS function recursively. And when we found a true on here, we immediately break it off and return the true. We don't have to do the rest. Otherwise, if we have explored all the four directions, and if we don't find a true in here, so that means we cannot find we cannot find an answer along all the four directions. We move from the exploring because we are not exploring anymore, and then we break it off by return a false. Okay, let's submit that. Oh, you already seen the result. For time complexity, it's gonna be big O over n times 3 to the power of L. Big O and n being the number of cells on the board. Basically, in this case, is m times n. And why is 3? Because we are exploring the four directions and we are not going back, right? So we could at most four directions to explore, but for the choice we do the 3 because we are not going back to where we came from. To the L, because L is the length of the word that we are given. So essentially, why is 3 to the power of L? Because for each of the letters, each one of the letters, we're exploring 3 directions. Right, so the first letter we have explored 3 directions. Second word we can explore like another 3 directions. So it times together, and we have n choices. Okay, for space complexity, it's going to be big OL because this entirely comes from the exploring set, and that's the maximum space that we need. Okay, so this is my solution to optimize this problem. I hope you find this helpful. If it is, please consider like and subscribe. Thanks so much for watching. See you next one. Bye bye.